So today we are going to learn about JBP in a very simple way. First of all, to understand JBP, we need to have an understanding of the cardiac cycle and what are the parallel phenomena that is occurring in the atria and the ventricle. So, as we know that there are three phases in atria and three phases in ventricle. So, atrial systole, atrial diastole, diastole continued. Ventricular, this is your atria, suppose. Ventricle. So, what we know is there is a ventricular diastole phase, diastole, and systole. Why I have drawn in this manner is because, like this, it will be very easy and very simple to understand JVP. What we know about ventricular systole or atrial systole, prior to that we have to understand that the entire cardiac cycle is for 0.8 seconds. So atrial systole out of that is 0.1 seconds, ventricular systole is 0.3 seconds. These are very basic things. When does a ventricular systole begin? S1 and S2, between the S1 and S2. What is S1? Tricuspid valve. What is S2? The pulmonary valve. I am speaking of the right side of heart because particularly we are now focusing on the JVP, which is a rough indicator of the right side. If everything remains normal, it also indicates your left side, but let us keep it simple. So, the very first wave of JVP that we know is due to your atrial systole, and that means your A will lie somewhere down here. So, this is your A wave due to your atrial systole, and the atria is pushing all the blood into your ventricles. Sorted. So, A wave. When will A wave be absent? It will be absent in few conditions like AFib, wherein your atria is having worm-like contractions or no functional contractions at all, or else also even your hyperkalemia, because you have seen as and when your hyperkalemia progresses, the P wave goes down. Now, when the atria will pump into your ventricle, what is the valve between? There's the tricuspid valve. So, anything that will be impeding the flow, like your TS, like your right ventricular hypertrophy, like any myxoma over here, it will keep your A wave high also. Secondly, this is your tricuspid valve. So everything passes down your tricuspid valve and there is a diastolic filling of ventricles. This diastolic filling is also indicated by what we know as the X wave, right? So this X descent, to be very particular. So anything like a TR or an RV failure, TR or RV failure, in all these things, your X wave will be diminished because this flow isn't going to be very proper. When will X descent be very high? It will be when there's a cardiac tamponade or a constrictive pericarditis. In both these situations, because the ventricle can't fill very naturally in its own diastole, that is your first rapid filling phase, the atria has to push much more blood into the ventricle, because in the end the ventricle doesn't fill up quite easily by itself, so atria has to give that extra push. So this X descent is very much prominent. It's very much prominent in which situations? In CP and CT, that is cardiac tamponade and constrictive pericarditis. Then we are moving on to the C wave, which has not much to speak about the C wave. C wave is due to the tricuspid valve bulge during IVC. What is IVC? I mean isovolumetric contraction phase. Not much to speak about it. Then, like your X descent, there's an X dash descent as well. Actually, the wave is like A, C, V. So A, C, V, and X, X dash, and Y descent. So this X dash descent lies over here. And what about X dash descent? Do you need to know that X dash descent is also an indicator of your right ventricular function, right ventricular status. So that is there. And then we have to move on to the V wave. Where is the V wave? V wave lies somewhere down here, and it indicates venous filling, which in turn indicates, venous filling means IVC and SVC filling, which in turn indicates your right atrial filling. Right atrial filling or the right atrial status. You can say V wave is an indicator of right atrial status. The V wave might be raised if your IVC filling and everything is high, or it might be raised when your RA filling is high. When is your RA filling high? Suppose there's an ASD. Suppose there's the RA, there's the RV, there's the LV, there's the LA. So V wave is an indicator of your venous filling, as I said, and RA filling. So RA filling can also be high if there's an ASD. RA filling can also be high when there's a TR. So any condition wherein the venous filling is raised or right atrial status is raised, you'll have a very prominent V wave. TR is a cause. Other causes are there. Then we have to move to Y wave. Now, what is Y wave? As the X wave was the diastolic filling, as the X wave was the systolic filling, atria had to do its systole to fill the ventricle. It is Y wave is the descent, what we call the first or early rapid filling phase. So this is your Y wave. So the more filled your right atria will be, the more pressure will be generated in the right atria. So there will be a high pressure zone. That means when there are all the conditions that will cause a very high V wave, this high pressure will push all the blood down into your ventricles. So you will have a very good, very deep Y wave. So what we can say is any condition that causes a prominent V wave will have a rapid Y descent. So any condition that has a prominent V wave will have a rapid Y descent. Okay. So why now coming to it is when your ventricle can accommodate, that is when the ventricle just starts its diastole, it starts filling, and that is your Y wave. Now the question is that in a condition like cardiac tamponade, when the pressure around the heart is so high, the ventricles can't accommodate much blood. So when this first rapid filling occurs from right atria to the ventricle won't accommodate and you won't have that Y wave. But in constrictive pericarditis have Y wave. In cardiac tamponade, because the ventricles are almost collapsed, because you will see the echo finding of pericardial tamponade, there's a right ventricular diastolic collapse. So right ventricle is diastolic collapse is there, which is the most specific sign on the echocardiography of a pericardial tamponade. So right ventricle is almost collapsed during the diastole phase. So you cannot expect any flow to occur during this. So almost all the filling in a case of cardiac tamponade has to occur due to the arterial pressure into the ventricle. That is what we know as the atrial systole, what we know as the late rapid filling phase of diastole. So in cardiac tamponade, as you can understand, the clinical picture is you will have a X descent, but you won't have this Y descent. In constrictive pericarditis, it is completely different. I have a very good slide explaining all these things in a good handwriting. So constrictive pericarditis will have most of the initial filling will occur. Like constrictive pericarditis, what is it? Just imagine an eggshell calcification around your heart. So what happens in constrictive pericarditis? There will be filling in your ventricles during diastole. There will be some resistance, but of course there will be filling in diastole, and there will be filling due to the systole as well. So if both X and Y will be there. But in cardiac tamponade, as I said, during the natural diastole of the ventricle is almost indented or almost collapsed. It will be very much collapsed in diastole. So this diastolic filling or Y wave will be never there, but this X descent will always be there. So this is the basic difference between tamponade and pericarditis. Remember that 75% of the venous filling occurs during this filling phase, that is Y wave. So 75% of the filling, the rest 25% is due to the atrial systole, and that is the X descent. Then what you have to know is, okay, all the blood came down here and that was your Y. All the blood came down and led to a very good Y descent. But say there's a condition wherein all the blood didn't come down. So you have some blood only came down. So your RA would be pre-filled. So it will be not, it won't be empty, it will be filled. So in those conditions you will find a shallow Y descent, and in all those conditions you will have an RA that is already filled. So in the next cycle you will have giant A waves. So what I mean by this is, any condition that causes a shallow Y descent will be a condition that has giant wave waves. Any condition that has prominent V will be having a rapid Y descent. So these are all explained in this picture. So if you learn the A, C, V, X, Y in this manner, it will be much simpler to understand. So another thing, that how to feel for this. So anything that comes before your carotid pulse, will be naturally A wave. Anything that comes after will be your V wave. What about C? C, they say, is the one that comes along with your carotid pulsations. So this is about the JBP waveform, and this is the clear picture that has the same things documented, which I will be attaching at the end of the video.